Namaste बच्चों, myself JV Dr. Monica Trivedi. Today's topic is characteristics of third transition series 5D series element of D block elements. Okay, so as previously we learned about first transition series and third transition series, the second transition series, and the third transition series shows the regular trend in electronic configuration of a valence shell like those of the first transition series also. So the general valence shell electronic configuration of these elements is 5D 1 to 10 S 6S 1 or 2. The last two elements, which are gold and mercury, have a completely failed 5D subshell, that is 5D, whereas the all other elements have 1 to 8 electron, which are 5D 1 to 8 in a D subshell of the shell. Okay, as have been given in the introduction that the only AU has 6s1 configuration and all the other element have 6s2 configuration in the last shell. The AU exchange energy effect plays an important role to cause the shifting of one 6s electron to 5d subshell so that it has a stable 5d configuration. Okay, so that is the 5d10 s 6s1 valence shell configuration, as was the case with the copper 3d and the silver 4d series. Okay, these three are the similar cases in a first transition, in second transition, in a third transition series. Okay, like the elements of the first and second transition series, the element of this series also exist in a various oxidation state in their compounds. The variation of the oxidation state is equal to the element of the all the three series like 3D, 4D and 5D series. This is due to the availability of the several electron in a 5D and 4S subshell whose energies are fairly close to each other. Like the element of the other series, and under difference condition differ, the number of the electron can be used for both the subshell for the chemical bonding. Okay, it has been observed that like a member of second transition series and the those of the first transition series, the higher oxidation state become more stable. Okay, but in a third transition series, the maximum oxidation state varies from +1 to +3. Okay, and like the lanthanum and Hoffman have a +3 electronic configuration in middle, +2, and last element has a +1 maximum oxidation state. It increases that the element up to the middle from the left at the highest oxidation state of the element is equal to the group number of the element. Okay, in this table you can see the group number, the lowest oxidation state and the highest oxidation state for each element. Here you can see the highest oxidation state is +8, which has a osmium, and the lowest oxidation state is has +1 and +2 for gold and silver. Okay, so you can see the +1 for both AU and HG, gold and silver, the highest oxidation state for which is +8 for the osmium. Okay, the next is a complex formation tendency. As you know that the transition elements are fitted for the complex formation. We learned it about earlier. These have some example for the complexes like for the hafnium, tungsten, rhenium. Okay, these are some complexes which made by the third transition series. Okay, so these are some example of the third transition series. Next is a magnetic property. As we know, the second transition series is a paramagnetic. Okay, the third transition series, the chemical substance may be diamagnetic, paramagnetic, or ferromagnetic, as we know. So the diamagnetic is a very the substance in the presence of the paramagnetic and ferromagnetic. Okay, the absence of the paramagnetic and ferromagnetic, the substance called as a diamagnetic. So in a third transition state, okay, the property of paramagnetic is a particularly explained in the term of the magnetic properties. The magnetic properties of the third transition series is calculated by Bohr magneton. This is the formula for the calculating the Bohr magneton or a magnetic moment for the third transition series. Okay, now the color of the ion, as you all know that the transition elements shows the color, exhibits the color, and these are the solid state or in a solution they show the changes from color to colorless by their oxidation states. Okay, so if we talk about 3D and 4D transition series element, the attachment, the attached atom, okay, which is a metal or a ligand, okay, are also responsible for the type of the color compound, because these affect the transition of the electron within the subshell or the between the subshell. The selection rule for the electron transition also play an important role in determination in the intensity of the color of the ion complexes or a compound. Okay, if any selection of the and any of the selection rules says that the particular transition is forbidden, but it occurs due to the breakdown of selection rule, the intensity of the color produced is low. If the transition is a forbidden, the color intensity is low or a dull. But if the transition is allowed, the intensity of the color is high or a fast. Okay, so this is the variation in a color of the third transition series element. Next is the catalytic property. You can see here platinum used as a catalyst, palladium used as a catalyst. Okay, so these are some examples which are used in a very much in oxidation reactions. Okay, the red hot, they become red hot, and they are used in many of the industrial purpose. Okay, these are some example of the catalytic reactions. Okay, next is the alloy formation. Alloy formation, you can see there are some example like silver and gold and platinum are used for the alloy formation. Okay, just like a 3D and 4D transition series, the third transition series also make the alloys by combine the other molecule. They also have a crystal form, and metal crystalline is a FCC type of the crystal lattice with a large number of planes. Okay, so this is the simple alloys. Okay, next property is atomic radii. Okay, atomic radii, melting point, boiling point, ionization energy. These are the periodic table properties which we have learned previously also for second and first transition state. Okay, the values of the atomic radii of these elements have been found to decrease from lanthanum to osmium. The element in the middle, and then they have increasing tendency up to the last element, which is Hg, mercury. The value are very close from tungsten and platinum because of the increased screening effect of the 5d electron, which neutralizes the nuclear pull extract on the 6s electron. Then the screening effect became more effective in the later electron. That two are still more last the for the last element. Okay, Hg, which has the atomic radius only less than the lanthanum. Okay, here you can see in this table the lanthanum has the highest ionic atomic radii. Okay, and there are this atomic radii decreases, and it further increases for the mercury. Okay, so next is the atomic volume. Atomic volume same as the atomic radii, the atomic volume decreases, and for the Hg the atomic radii is increases. Okay, so this is the ionic radius. Here you can see the ionic radius as well as the atomic radii is highest for the lanthanum, and it will decreases gradually, and for the mercury it increases because of screening effect. Okay, now the melting point, the melting and boiling point of these elements are very high expecto for the mercury. Okay, as we know mercury is present in a liquid, है ना? So mercury is a liquid. A physical state of the mercury is liquid, so it is a melting point or a freezing point is a minus 38.4 degree centigrade. So in this table you can see the melting point for the third transition series. It is gradually increases, then suddenly it is dropped down, and mercury is a liquid on a temperature. So these are the variation in a melting point of the third transition series. Then after the ionization energy, what are the ionization energy? You can see in this table that ionization energy is increases. The first ionization energy value of these elements increases gradually as we move from left to the right in a series for lanthanum to mercury. The value of in a kg of mole has been given in this table. Okay, if we compare the first ionization energy of the element of the second ionization series, it can be observed that deuterium has a higher value than the lanthanum. Both member are the member of the group third due to the similar size. From Hoffman to Hg, these elements have the higher value for the first ionization energy than those of the element of the second ionization energy. Okay, so the ultimate result in the higher value of the first ionization energy for those elements, Hg has the appreciable high value of the first ionization energy because more energy is required to remove an electron from stable 5d10 s 6s2 configuration of these elements. Okay, then the oxidizing and reducting properties of the uh, third 5D transition series. For the 3D and 4D transition series elements, some elements are shows the oxidizing and reducting properties. Okay, so for the third transition series, we can see for the gold. Okay, so you can see the gold and platinum are used as a oxidizing agent here. Okay, mercury, platinum, these are some examples. Okay, these metals may thus act as a oxidizing agent and have the tendency to take up the electrons. So this is the general properties of a third transition series of a d block element. Thank you very much.